Hello everyone, I'm Saad Salman. I'll be your teacher for this part of polynomial functions. And this is our website which you'll be visiting and learning a lot. Hope you all come back to this website and learn more from us. And today we'll learn a lot about polynomial functions, their physical properties, their characters, and everything till sketching of the polynomial functions. And then from the next lesson, we'll continue from types of polynomial functions. So yeah, let's start. So the first thing we'll study would be characteristics of the polynomial functions. So a polynomial function is a function that can be expressed in the form of a polynomial. A polynomial is generally represented as px. The highest power of the variable of px is known as its degree. So the degree of a polynomial function is very important as it tells us about the behavior of the function px, where x becomes very large. So the domain of a polynomial function is the entire real number, which is also called R. So that could be a bit confusing in the questions, but we have to keep that in mind. It's R. So yeah, let's continue. If Px is equals to an x n power n plus a n negative 1 x n power n minus 1 plus there's a gap plus a 2 x square or x power 2 plus a1 x plus a0. Then for x greater than 0 or x smaller than 0, px would be the same, which would be a n x power n. So thus the polynomial functions approach power functions from a very large values of their variables. Giving an example, a polynomial function has only positive integers as exponents. We can even perform different types of arithmetic operations for such functions like addition, subtraction, multiplication, or division. So some examples of the polynomial functions are here, giving an example of x squared 2x negative 1. So these expressions are not polynomial functions because they have a negative in them. If we put a positive in the place of negative, it could be a polynomial function. And giving another example of 5x negative 1 power plus 1. So this is also not a polynomial function because its power is in negative 1. And if it doesn't matter if the power is in negative 1 or the two values are in negative, it would not be a polynomial if there's a negative sign. So yeah. Now we'll study the characteristics of polynomial function. I mean, we have been studying it before, so we'll go into more depth. We know about degree, domain, and range. We have learned about them in junior classes, so we'll continue. Degree is the highest power in the polynomial function, and domain and range are all real numbers, except range are all numbers which have upper and lower bounds. So that's the difference between domain and range. And the next is odd and even degree. If a function's highest power is odd, it is an odd degree polynomial, and if a function's highest power is even, so it's an even degree polynomial. Next, we have the end behavior. The end behavior is the sign of a leading coefficient that tells us about the end behavior of the graph. So, for example, giving if we have a negative sign, negative 2x plus 1, if that is an equation, then the graph would be 2x minus 1, negative 2x minus 1, or only 2x minus 1. Then the graph would be having a sad face, because as we all know, as we have studied in the junior classes, when there is a positive sign, it is a happy face, and when it is a sad face, it's a negative sign. The note here is the end behavior is only determined by the sign of the highest degree. So for example, what I said was if there is negative 2x, negative 1, so this graph would be sad face. Negative 2x plus 1, sad face. Plus 2x, negative 1, it would be a different case. It would be a happy face because there's plus 2x, of the first of all the highest degree. And sometimes the highest degree is the leading coefficient. Many students get confused, but we have to keep in mind that the highest degree has to be seen, not the leading coefficient. Next, we have local minimum and maximum. So the greatest slash least value attained by a function for an interval is called the local minimum and maximum. And absolute maximum slash absolute minimum, it is the greatest slash least value attained by a function for all values in its domain. This is very important to know, in its domain. Many students make mistake here. Next, we have a stationary point. For a function y is equals to fx, a stationary point is a point on the function's graph where the slope of the function is 0. It is neither increasing nor decreasing. And the last is the turning point. If the slope of a function changes the sign at the stationary point, then it's called a turning point, which can be a local maximum or a local minimum. We go in more depth about these characteristics. Odd and even degree polynomials. So the highest power is always considered as the odd slash even degree definer. Giving an example, x squared plus x plus 1 is an even degree because the highest degree is positive. And highest degree is positive, is even, sorry, not positive. It's positive, but it's even. And the next one is x cubed negative 2x plus 4. So this is an odd degree because the power of x is cubed, not even, not even degree. And we have to look at the leading coefficients as well. We can only determine by looking at the leading coefficients. And in the odd slash even degree polynomial, all the exponents should be odd and even. Yeah, that's what I just said. Giving example, x squad or x power 4 plus x squared plus 2. It's an even degree polynomial because in even degree polynomial and even degree, there's a difference that in even degree polynomial, all the values have to be even or odd to in order to get a positive value. And plus if um, there's negative value and positive value side by side. So next example is what I'm just saying: x cubed plus x power 5 plus 8. So we can see x cubed and x power 5 are even, and plus 8 is are odd, and plus 8 is even. So in this case, we look at the highest power, not the highest number. So the highest power is x power 5. So it's an odd degree polynomial. Domain of a function f of x is the set of all values for which the function is defined. So the range of any polynomial function of odd degree is y is equals to minus infinity, comma positive infinity. So the range of a polynomial function of an even degree is bounded either from below or above because the function will always have a maximum or a minimum value. Next, we have the family of the polynomial functions. Family of a polynomial function has a basic formula. Fx is equals to ax minus bx minus qx minus r. Sorry, there's a mistake. And x minus q, there's written x minus 9. All right. So to sketch the following family functions, we plug different values for k. So the following polynomial function is right here. F of x is equals to negative bracket open x plus 2 bracket close bracket open x negative 1 bracket close x bracket open x minus 3 bracket close whole squared. And to sketch the following family function, we plug different values for k. For example, f of x is equals to k bracket open x minus 2 bracket open x plus 3 bracket close. And the polynomial function in a factor form, example 1, analyzing an equation. So analyze the equation, we just write it again down, and then we analyze by looking at the degrees, turning point, sign, leading coefficient, and different things. So the degree is 4, which is even, and turning point is up to 3, starting from 1, 2, or 3. And sign of the leading coefficient, or we can call it LC, is negative, and the graph would be downwards. So, and the zeros 2 order 1 and 1 order 2. And the x and y intercepts are x intercept as y is equals to 0 minus 2 comma 1 comma 3, and the y intercept is x is equals to 0 0 plus 2 0 minus 1, 0 minus 3 whole squared. Next, we have a question right here. Write the equation of a cubic function that has zeros at minus 2, comma 3, comma 2 over 5 and has the y-intercept at 6. F of x is equals to ax minus bx minus qx minus r. Thank God the formula is right here. Alright, fx is equals to ax plus 2x minus 3 and 5x minus 2. So we substitute 2 over 5 like this in this type of questions. So substitute x is equals to 0 and y is equals to 6 because we don't have a value for x-intercepts just yet. So we will put 0 and we have a value for y-intercept at 6, so we'll put 6. And 6 will be substituted in the place of f of x because f of x is also y. So 6 is equals to a 0 plus 2, 0 minus 3, 5 bracket open 0, bracket close minus 2. In here we had to find a, and as we don't have any value for a, so we will find it by like this. So the value of a is equals to 1 over 2. And in the end, we'll substitute all the values in. Fx is equals to 1 over 2, x plus 2, x minus 3, 5x minus 2. Just we have to find the value of a so that we can substitute its value to make the complete equation. Write the equation of the right graph. Fx is equals to ax plus 2 whole square x minus 3 whole square. Substitute x is equals to 2 and y is equals to 4. So 4 is equals to a bracket open 2 plus 2 whole square bracket open 2 minus 3 bracket close whole squared. So again we have to find the value of a is equals to 1 over 4. So f of x is equals to 1 over 4 bracket open x plus 2 whole square x minus 3 square. We have different types of graphs now. Quadratic graph is one of the types. Fx is equals to x square. I just told you in the beginning that everyone in the beginning that whenever we have a positive sign, so it's a happy face. So x square is a positive sign. It has a negative. It has a positive face, so a happy face. And fx is equals to negative x squared means a sad face. Now we have cubic graphs. Fx is equals to x cube. Just as the name says, we have cubic graph. So x cube positive happy face or a slant shape on both sides, and fx is equals to negative x cube. So just opposite of the positive shape would be. Quadratic graphs. Now, quadratic graphs and quartic graphs are different because of x squared and x square. So yeah, x squared again happy face, but this time we can see the graph is a bit wider. It's not very thin. And fx is equals to negative x squared. So just the opposite, and it would be a sad face. Now the general form of the polynomial transformation would be general form of transformation is 1 second, sorry. Okay, general form of polynomial transformation would be y is equals to af kx minus d plus c. So we substitute values in it where n is the degree of the polynomial, y is the by the factor of a, and translated c units to the to up or down x, and it is stretched and compressed by the factor of 1 over k and translated d units to the right or left, depends on the situation. This is stretched. All right, I'll just move on. All right, the coordinate of p x comma y after a transformation would be g plus d comma a y plus c. And next, transformation of the polynomial function. And we have a question right here. Describe the transformation which were applied to the parent function to get y is equals to 3x minus 4. So it's a simple question. And then we have parent function as y is equals to x. General form is a formula is y is equals to ak x minus b plus c. And the transformations are vertical stretch by a factor of 3 and vertical translation 4 units down. Now we have another question. Describe the transformations which were applied to the parent function to get y is equals to negative 4.8. bracket open, x minus 3, bracket close, x minus 3 again. So we'll just whole square these x minus 3 because they are 2. So the parent function would be y is equals to x squared, and general formula is y is equals to akx minus d plus c. So the transformations are reflection in the x-axis and vertical stretch by a factor of 4.8, horizontal translation 3 units to the right. And the next one which we have is the transformation of the polynomial function. So we have to describe the transformations which are applied to the parent function. Again, y is equals to negative 8 bracket open 1 over 2 x plus 1 bracket close whole cube minus 3. So the parent function is y is equals to x cube. General formula is y is equals to akx minus d. So look, here's the difference. We have a power now, power of cube. So we'll have a power x after x minus d, both brackets closed, power cube plus c. So the factor, the coefficient of x so that the function is in its general form. So now we'll have a function y is equals to minus 8 bracket open 1 over 2 x plus 2 bracket close whole cube negative 3, and it's vertically translated by a factor of a reflected in the x-axis, horizontally stretched by a factor of 2, horizontally translated 2 units to the left, and vertically translated 3 units down. And last but not the least, finding the equation of transformation function y is equals to x cubed. So we'll again put it in the formula. So the translations are 3 units to the left, translated 4 units down. Equation of the function would be y is equals to x plus 3 whole cube negative 4. And sketching the graph is the last thing which we'll do today. Find the intercepts first, then check for the symmetry, use the multiplicities of the zeros to determine the behavior of the polynomial at the x-intercept, then describe the end behavior by examining the leading term, and use the end behavior and the behavior of the intercepts to sketch the graphs. So we can look at the equation and sketch the graphs very easily. And now we'll continue from types of polynomial functions from the next class. Thank you all. It was a fun class today.